Hi everyone. In this lecture, we shall see the topic chi-square test. First, let us see what is chi-square test. Chi-square test is used to test whether difference between observed and expected frequencies are significant. Test statistics for chi-square test is given by chi-square equal to sigma O minus E the whole square by E, where O is the observed frequency, E is the expected frequency. If the data given in a series of n numbers, the degrees of freedom is n minus 1. In the case of binomial distribution also, the degrees of freedom is n minus 1. But in the case of Poisson distribution, the degrees of freedom is n minus 2. And in the case of normal distribution, the degrees of freedom is n minus 3. Uses of chi-square test. Chi-square test for a specified population variance. Chi-square test is used to test whether difference between observed and expected frequencies are significant. Next one, chi-square test is used to test the independence of attributes. First, let us see a problem. The following data gives the number of aircraft accidents that occurred during the various days of a week. So here the accident details are given. We have to test whether the accidents are uniformly distributed over the week. So here the expected number of accidents on a day is 90 by 6 is equal to 15. Now let us set up the null hypothesis H naught, that is accidents occur uniformly over the week. Next, set up the alternative hypothesis H1, that is accidents do not occur uniformly over the week. So here the corresponding days are for the observed frequency for the corresponding days are given, and from this the expected frequency is calculated. The expected frequency is the average of all those observed frequencies, which is 15. Next we have to calculate OI minus EI and then OI minus EI the whole square by E, and we have to find the summation of all those values. So the test statistics chi-square equal to sigma O minus E the whole square by E, which is 1.998. So here we have 6 observations. Therefore the degrees of freedom is n minus 1 equal to 1 minus 6, which is 6 minus 1, which is equal to 5. Now from chi-square table, for the degrees of freedom 5, we have chi alpha square value is 11.07. Now let us compare the calculated value and the table value. Clearly the calculated value chi-square is less than chi alpha square. Hence we accept the null hypothesis H naught. So the conclusion is accidents are uniformly distributed over the week. Now let us see one more problem based on this. A survey of 320 families with 5 children each revealed in the same distribution, in the following distribution. So here number of boys, number of girls, and number of families are given. We have to check the consistent with the hypothesis that male and female births are equally probable. This is the problem. Set up the null hypothesis. This is the first step. That is male and female births are equally probable. Then set up the alternative hypothesis H1. That is male and female births are not equally probable. So let us find the P and Q values. This probability of male birth is P equal to 1 by 2 and the probability of female birth Q is equal to 1 by 2. Because by obviously the probability will be 1 by 2. Now the probability of x male births in a family is P of x equal to 5cx p power x q power 5 minus x. X varies from 0 to 5. Expected number of families with x male births is 320 into above P of x value. So now the chi-square is calculated using the following table. So here number of boys data are given, observed frequencies are known, and expected frequencies can be calculated from the above expression. Now O minus EI value is calculated, then OI minus EI the whole square by EI value is calculated. Sum up all those corresponding values. So we have chi-square value is 7.16. Now let us compare this with the table value. Here the degrees of freedom is n minus 1 equal to 6 minus 1, which is 5. Here the level of significance alpha is 5%. So we have chi alpha square value is 11.07. Here now compare the calculated and table value. Clearly the calculated value is smaller than the table value. So we accept the null hypothesis H naught. So the conclusion is the male and female birds are equally probable. This is the required conclusion. Thank you.